Let's, I'll just get a piece of paper out of the way, so that's coming there. Let's look at where we left off last time. Want to finish off the continuity one. There's a couple of questions at the end, and they both deal with piecewise functions, evaluating them, sketching them, and then looking at left, right, and overall continuity. So the first one I'm going to do, can't remember which one is. I think it's a version of question 21, but question 22 is very similar, so it might be clearer. And we have a function, and it's described in the piecewise notation where it looks like this. It takes on the value 6x squared for values of x that are less than 1. 6x squared. Takes on the value 6x for x in the range -1. By the way, that should be -1. -1 to 1. And then it finishes with, it takes on the value of 6 over x for x greater than or equal to 1. Now, if you've not had a lot of experience with piecewise function, essentially the rule that you use changes depending on the value of x. So one of the questions that they give you in the homework is they say to you something like, find the value of f of -1. Now, to be a real function, there can only be one answer for any given value of x. So there can only be one of these three rules, these formulas that we should use. And when we look at where -1 is, isn't it in this middle range? Right, so -1. So when they want to know the value of f of -1, you would just put in 6 times -1. Right, so the answer to that would be -6. On the other hand, if they asked you for the value of 1, you would look through this list and you see, well, it's this rule here that's going to be used. In this case, it would be 6 over 1, which is 6. And you could certainly do lots and lots of values and eventually sketch that. But a piecewise function is really made up of, in this case, 3 pieces. Sometimes you just get like 2 pieces, that's more common, but it's a little bit difficult to draw. And because you really want to sketch it to find out if there's any places where it's discontinuous, right? Any places where there might be a break, like a jump discontinuity, perhaps, something like that. And so what I'm going to show you now is how you can take this function, this piecewise function, and let Desmos sketch it for you. I've already set this thing up, so I've spent a little bit of time getting the windows right. So don't expect it to come out as clean as this one did. You have to make the window go big and small and adjust the X's and Y's, but eventually you're going to get this guy. So this is how you type it in. I think I may have to open this up. There we go. Y equals 6x squared was the top one. A little, what I call curly brackets. X less than -1, finish the curly bracket. That tells Desmos to draw this guy here. Then you do y equals 6x, which was our middle one, and you make it from x equals -1 to 1, and that makes it draw this piece. And then you do y 6 over x for x greater than or equal to 1. So do you see these 3 lines here, don't they? Basically, that's what the piecewise function looked like. You know, the one I had in the paper, right? You know, less than this, between these, greater than that. And now piecewise has done it. And what I've also typed in is that when x was -1, the value was -6. And when x is 1, the value is 6. Remember, I found the value of f of -1 and the value of 1. Yes, Maddie, what's your question?
So during like we use Desmos to like see the graph like of the piecewise functions. Are we able to do that on our tests?
Yes.
What
yes.
about, so are we ever going to need to know what functions look like if we can't use Desmos?
No, since you'll be able to use Desmos, you don't need to know what functions look like. But the types of functions you're most likely to meet, the ones you're most likely to meet, you've seen them. There's not anything weird going on. I mean, if you've done 141, you've seen every function you need to see anyway, so you should be familiar with them. But Desmos is always going to be there for tests and homework. So you would If you weren't sure, you could just go in and Desmos it. So if you type the point, it gets you, I believe, that guy. And if you type this point, you've got that. So I've essentially got a very colourful version of what this piecewise function looks like. Now, if I asked you a question like, where does this function have a discontinuity, right? A place where it's not continuous. Would you agree there's only one place where it's not continuous? And that's x equals -1. And we would call that a jump discontinuity. Right? Now, I haven't found out how to make Desmos do it, but see this guy up here? Shouldn't there be an open circle there? I just don't know how to make Desmos plot open circles. I know how to plot solid filled-in dots, but I haven't figured out how to make it an open circle. So can you just pretend there's one there? Now, I could also ask you, what is the left limit as x approaches -1? And what is the right limit as x approaches -1? Right? We could ask you limit questions that you should be able to get from this. So if someone says the left limit, you're coming in from the left-hand side, right? This guy over here, the left up. Well, I've got to be careful. See, when I do this guy over here, have you noticed that my hand is pointing to the right? I'm actually pointing to the left in real life, but the camera reverses my direction so that when I write, you can see it. It's something to do with the way cameras work. That if I look the right way, when I write my writing on the paper, it would be back to front and look weird. Anyway, just to point this out, I may be saying to the right, but really I'm doing left. So try not to watch my picture sometimes. Okay, so here we go. On this picture, as you approach -1 from the left-hand side, do you see that the limit is approaching 6? The right limit is as you're approaching -1, right, coming down here, it's going to go to -6. So the left limit was -6, the right limit was +6, and the overall limit therefore does not exist. Right? Nothing else really going on in this picture. Would you agree that there isn't a problem at 1? Don't the two pieces meet up in the right place, right? So that would not be a problem. That would not be a discontinuity. Any questions about that? Are we good? Right. The other one, question 22, goes through very similar types of questions. So you can just hold off a second. I'll actually just quickly. Oh, I can't. Okay, just trust me then. I was going to show you, but I closed the window. 21 and 22 are use Desmos to sketch it, find the value of things like f of 1 and -1, and then it finishes with left limits, right limits, and overall limits. And that's pretty much it. So we are ready to start our next section. So let's get into that. Right. Our next section has got a lot going on. We're going to look at limits at infinity. What you would probably describe in 141 as functions that have vertical and or horizontal asymptotes. We are going to look at how to find these infinite limits. So let me start with some notes. Let's look at some functions, and let's look at, for starters, the different types of vertical asymptote shapes that you're likely to encounter and what their limits would be as you approach a particular value of x. And there are 4 of them. And I'm going to have them all at the same place just to make my life easy. And we're going to have them all at, say, x equals 3. So they're going to be a vertical asymptote at x equals 3. And we're going to show you the different kinds of vertical asymptotes that typically can happen. You could get a vertical asymptote. That looks like that. Right? You've seen them in 141, right? I have names for them. I call that a volcano. So if you ever hear me talking about a vertical asymptote that's a volcano, I'm basically describing that, right? Because it looks like a volcano to me. Now, for this fella, the overall limit as x tends to 3 is plus infinity. That's an acceptable answer. That's what they want. Now, I could find a left limit and I could also find a right limit for that. Would you agree that the left limit, as you come in from the left-hand side, is plus infinity? And if I asked you to do a right limit coming in from the right-hand side, then it's also plus infinity. Now, I don't have enough room or interest to write them down, but I could have written the limit is x tends to 3 plus and the limit is x tends to 3 minus, and everything would match. Now, you could get a vertical asymptote that looks like that. And if you did, then the limit, the overall limit as x tends to 3 of this function, wouldn't that be negative infinity? You agree? Overall limit, negative infinity. I call these kind of vertical asymptotes holes in the ground. So they're just made up names, right? I call them volcanoes. I call them holes in the ground. Now, same kind of thing here. Couldn't I have said the left limit was negative infinity and the right limit as x tends to 3 is also negative infinity. And that's why an overall limit does exist. Now it says there's 4, so here's the last 2, just to remind you. You could have one where it went like that, then it went like that. Now this is a little bit messier. We will do the left limit, right? 3 minus, left limit. That answer, it has a limit of plus infinity, right? Left limit, plus infinity. Right limit. Well, as you come in from the right-hand side, don't you zoom down the way? So negative infinity. Now, hopefully we've done enough limit work to realize that in a situation where there's a left limit and a right limit, but they don't agree, doesn't that mean that the overall limit does not exist? I don't know if you can see that, so move up a little bit. Right. Now, if you look at the fourth one, the third one and the fourth one kind of look very similar to each other. The only real difference is that this side it goes down the way and on this side it goes up the way, right? So technically they are slightly different, are they? You know, they have kind of switch over. Very similar results, of course. We have a left limit. We have a right limit. And we may or may not have an overall limit. Okay, for this vertical asymptote, what would be the value of the left limit, the 3 minus 1? What's the left limit?
Negative infinity.
Agreed. Would you agree then that as you come in from the 3 plus side, the right limit is positive infinity, and so that this does not exist? And if you're interested, I call vertical asymptotes that look like these guys, I call this one of each. Right, so it's got one of each, right? Volcanoes, holes in the ground, one of each. Now, since there's only a limited number of things that can happen with a vertical asymptote, your answers are quite limited. Aren't your answers going to be plus infinity, negative infinity, or it does not exist? Right, it's not like a number where you could, it could be 5 or 55, right? It's just got plus infinity, negative infinity, or does not exist. So if you were a gambling person, couldn't you guess the answer and you'd be right 1 in 3 times? Not that it's a good math way of doing it, but just to show you the limited things that you can do. So what we're going to look at now is then, suppose I gave you a function and I wanted to know what its limit is as x tends to a point where there's a problem, right? Would you agree that this function, and they're almost always going to be, fractions with vertical asymptotes in them, right? So that's pretty common shape. Would you agree this function has a problem at 2? And I'm trying to find the limit as x tends to 2. Now, the first way to do it, couldn't I just plug that into Desmos and see, maybe I'll get a volcano, right? In which case the answer is plus infinity. Maybe when I plug any Desmos, it looks like this, in which case I'll get negative infinity. Maybe I'll get this guy or this guy, in which case that answer would be does not exist, right, for example. And so one method is, put it in a Desmos. I'm going to show you 2 other methods. We're going to show you essentially a numerical method where you just do a table of values, and and an algebraic method, very often called brute force. Right, well, let's do the table of values method. Pen's going a bit wonky. So you set up x, you set up f of x, and you look for values of x close to 2. Now you can't put 2 in because don't you get 2 over 0 and 2 over 0? It's bad news, right? You're not quite sure what's going on when it's that. Could be plus infinity, could be minus infinity, could be it doesn't exist, it goes both ways. So since I'm interested in 2, I'm going to pick 1.9 and 1.99. So you pick 2 numbers just to the left of 2, right? Smaller than 2. And then you pick 2 numbers that side. It would be better to pick, instead of 4 numbers, 6 or 8. But I think you can get away with, 4 if you're just looking for a pattern, right? You're not going to push it too much. So I'm going to go in y equals, and it's going to be x divided by brackets x, take away 2, close brackets, squared. So that's the function. And I'll do setting table, rub out these guys, and just put in 1.9, 1.99, 2.01, and 2.1. Right, it wasn't that bad. And this number here, the value of the function is 190. And in this side here, it's 199,000, so that's 19,000. Here it's 20,100, and here it's 2,210. Now, if you can't see enough pattern there, couldn't I put a 1.999 in and a 2.001? But it's pretty clear to me that as you're traveling this way and as you're traveling this way, right, you're trying to meet in the middle. Would you agree both of them are very big and positive, and therefore both of them are going to end up being plus infinity, in which case I will be able to put in the answer plus infinity here, right? Now, in a different question, can you imagine this happened? Well, in this case, wouldn't this direction be plus infinity, but this direction would be negative infinity? Wouldn't that be actually one of each? And when that happens, won't your answer then be DNE? Are we comfortable with that idea? That you can actually, by a table of values at least, you can find vertical asymptotes relatively quickly. Right, so stick it in Desmos, do a table of values, you come up with the same result. Any problems? Now, just to show you that the world can have weird results. Let's do that one. Would you agree this one has a problem at 0? So there may or may not be a vertical asymptote here. Why do I say there may or may not be? Because that top guy is sine x. If that top guy had been, x plus 1 or something, we'd probably get away with a different result. So I'm going to set up our table of values, and we're going to use it on this situation. Now, since I'm interested in getting close to 0, how about negative 0.1 and negative 0.2 zeros and a 1, and positive 2 zeros and a 1, and positive 1, right? So now I'll go to my calculator. I'll make sure that I'm in radians, because all calculus is radians, and I will type in sine x divided by x. And something surprising is going to happen. I'll go second table, clear out these guys. Okay, why? No. So it's going to be sine x divided by x. And why did I do that? Negative 0.1, negative 0.001, positive 0.001, and positive 0.1. And the answers that I got are 0.99833. That guy there that says 1, if I go over here, can you see it's actually 0.99999 and some 8s. And this one is 9, probably some 8s. And the last one is 0.99833. Now, as you approach from this direction and as you approach from that direction, would you agree that the answer isn't plus infinity, the answer is not negative infinity, and the answer isn't even it doesn't exist? Would you agree that it's homing on the number 1? Now, I put that one in just to get you used to the idea that not everything is a vertical asymptote just because the bottom is 0, right? You could get something that has a 0 on the bottom, as this one would have, agreed, that has a limit that's not infinite. But the ones you are going to deal with in your day-to-day world are going to be these guys, right? So this is just a special case. So far, so good. Now, let's look at the other kind of infinities. Let's look at horizontal asymptotes, things that happen when you make x infinite. So, for instance, suppose I wanted to know the limit as x tends to infinity of 2x squared plus 1 over 3x squared minus 4x plus 7. When you do the limit as x tends to infinity or the limit as x tends to negative infinity, what you're really looking at are what does the function do to the right hand side. So as x gets really big, what does it do? Now in 141, there are a number of things that could be. So we'll come back to that question and we'll just look at what it could be. Couldn't the function level off on the x-axis? In other words, it gets closer and closer to the x-axis. If that was the case, then the limit as x tends to infinity of this function would be 0, right? It could be this situation. that it levels off, but at some other number. Maybe 2/3, for instance, right? Can you remember 141 when you were doing horizontal asymptotes, that they could level off at height, in this case of 2/3, or 5 or 42. So in this case, that would be 2/3. And the third, there are actually 4 possibilities, but the third major one that you're really going to deal with is that couldn't the function just zoom off to infinity? Right, as x gets bigger, doesn't the answer to the value of y gets bigger as well? In which case, you could have plus infinity. I guess I could have put a second version, but I think that covers it. Couldn't I zoom down the way to negative infinity as well? So these type of infinite limits, right, the limit when x tends to infinity, fall into the answer is 0, the answer is a number, or the answer is infinity. There is a fourth possibility, and I'm not really going to deal with it because we don't need to, but essentially, couldn't you get a function that just wobbles up and down like cosine x, right? It doesn't go up forever, it doesn't go down forever, it just wobbles around. Can you imagine one of those trig functions that might do something like that? But we're not going to deal with trig functions, so we'll just pretend they're not. They don't exist for right now. So these are the situations you're going to get. So how do we find the limits of that? Well, I could plug this into Desmos. And if I did, I would at least get a feeling for whether it was leveling off up here, or it was leveling off down here, or if it shoot off to infinity. Now, if it shoot off to infinity, that would be easy, right? If it just looked like it was going uphill forever, I could just write plus infinity and we'd be good. If it's leveling off, it might be easy to tell when it's leveling off on the x-axis and say 0. But if it's leveling off at a number, that's the hardest one. Won't it be quite difficult to know if the answer is 2/3 or 0.6? Right, you know, you're never quite sure. So Desmos has a kind of weakness in these questions, right? I don't think Desmos has a weakness with vertical asymptotes. Would you agree vertical asymptotes are pretty obvious what they're doing, right? But horizontal asymptotes, not so obvious. So we won't really even do a Desmos one. We're going to go and do numerical, and then I'll do algebraic. So I guess I'll write it down here again. The limit as x tends to plus infinity of 2x squared plus 1 over 3x squared take away 4x plus 7. If I was interested in finding what that limit is, I could simply do a numerical estimate of it using a table of values. So I'm interested in x tends to infinity. So I could do x is 10, x is 100, x is 1,000, and then x is say 1,000,000. Would you agree that would be nice little test points on the road to infinity, right? And for each one of these, we will find the value of this function, which is what your TI-84 is really quite good at doing. So put in y equals, put a bracket around it, as we always should by now, because we've mentioned it a lot of times, the order of calculations can screw things up if you don't put brackets in. So we got that guy. Then over to the setting table, rub out these guys and put in 10, put in 100, put in 1,000, and put in, hopefully that's 1,000,000. Let's see what our answers look like. It's about 0.75 to 2 decimal places. It's about 0.676 if you go to 3 decimal places. It's 0.667 if you go to 3 decimal places, and it's 0.66667 on the last one. As you get bigger and bigger values, would you agree that this function is getting closer to one particular number, right? It is leveling off, isn't it? And I guess you could say it's leveling off to 0.66667, but let's do a conjecture, right? Let's do a sensible guess. What fraction do you think that is?
2/3.
I think it would be 2/3. Would you agree? 0.66666, 2/3. So here is our estimate. Technically, it's an estimate right now. That this limit is 2/3. So it would be one of these ones, wouldn't it? Level off at 2/3. Now, let's show you an algebraic method. And let me hold that for a thought. We're going to do a technique that basically is an algebraic method, and we're going to use a thing called brute force. So before we continue with that, I want to start off by telling you some results that we will assume are obvious. 1 over x, as x becomes infinity, you can do brute force. Essentially, that means make x infinite and do a calculation. What number is 1 divided by infinity eventually going to become as a limit? What number is 1 over infinity?
It'd be 0.
It'd be 0. Now, if you wanted to do 1 over x squared as x tends to infinity, that would become 1 over infinity squared, which I could just call 1 over infinity. See, infinity is a weird thing when you calculate it. Would you agree that infinity times itself is just infinite? It doesn't, it's not like 4 times 4 turns into something else, right? Infinity times infinity just turns into infinity. And isn't that 0? Now, what would happen if I stuck a 10 here? What would 10 over infinity get you? That's got you paused.
Still be 0.
Still be 0, won't it? 10 divided by an infinitely large number gets you 0. And what would negative 11 get you then?
Same thing, still 0.
Still 0. Isn't calculations with infinity kind of weird? Now, continue with this process. Let's do that guy. As an infinity calculation, basically we call this brute force, right? I would get 5 infinity squared plus 1. Okay. Would you agree infinity squared is still infinite? Would you agree 5 infinities is still infinite? Would you agree 5 infinities add 1 is still infinite? Have you got a theme here that things tend to be 0 in all of these cases? So we're going to use this idea that we can estimate the value of various combinations where, as long as the bottom has an x in it or something, right, we're good to go, right? Let's look at this situation now. Suppose I wanted to find the limit of x divided by 3 as x becomes infinity. Well, according to brute force, I need to find out what infinity divided by 3 is.
Infinity?
Yes. If it was x squared, wouldn't the answer still be infinity? most questions, most situations that involve the limit as x tends to infinity, don't you get zeros out of them or some type of infinity? Now, I could change these to negative infinity. It wouldn't have any effect on this because 0 is 0, whether it's negative or positive. But if I changed it in some of these cases, it might make a difference. So let's put one in just to show you. I'm going to plug in negative infinity. Right? I'm going to do brute force. So that's going to be negative infinity cubed, add 7, all over 10, right? Okay, here's our first PCR calculation. What would you get if you took negative infinity and you cubed it? So you
Negative
went,
infinity.
agreed. I don't want you to let this one freak you out because it's not actually, shouldn't be freak outable. What do you get if you take negative infinity and just add 7 to it?
You still have negative infinity.
And what would happen if you took negative infinity and divided it by 10?
You're going to get 10 negative infinities, so you got negative infinity.
Great, you get a 10th, you get negative infinity. So one more, and then we'll return to our question. So we're going to look at what that fraction looks like as x tends to negative infinity. It's going to be 2 lots of negative infinity squared, take away 100, right? All over 3. So, better to do things slowly till you get good at these. What happens to negative infinity if you square it? What do you get?
Positive.
Infinity, right? Would you agree that 2 times infinity is still positive infinity? Right, infinity take away 100.
Still infinity.
Divide that by 3.
Infinity.
And so we have got our answers. Have you noticed that almost every brute force question that we have done, the answer ends up being 0 plus or negative infinity? Do you see when you calculate with infinities, you don't get a lot of choice in what you end up with? Would you agree? You tend to end up with plus infinity, minus infinity, or zeros, right? That's the typical final result at the end of the kind of calculations we're going to deal with. So now that we've got that guy under the belt, I was going to show you, and I will, how to do this one here. We already believe that the answer is 2/3. We are going to do it algebraically. So here it is. In fact, most of the questions in this section, you're going to do this method on it. Now you might think, oh, well, you're just going to brute force it. You're going to plug infinity into the top and infinity into the bottom. No, I'm not. If I did that, wouldn't the answer I get is infinity over infinity, and then we'd have a problem? And you might say, oh no, infinity over infinity is 1, right? Because 7 over 7 is 1 and 20 over 20 is 1. So infinity over infinity is 1, and you'd be wrong. Infinity is it's like clouds. You can't grab them. You try and they just disappear on you, right? You think you've got a grip of what the thing is, and then it just goes and does something stupid and confuses you again. Infinity over infinity is called indeterminate form. It means we do not know what it's equal to. Would you agree that 0 over 0 is the same situation, right? You don't know what 0 over 0 is either, right? So we have to adapt to the situation. And so what we do here is a rather clever piece of algebra. I am going to essentially divide the top and the bottom by a power of x, not just a random power of x, the biggest power of x that you can find anywhere in either the numerator or the denominator, right? I don't care where it is. Would you agree in this case, the biggest power of x is x squared? And once I've figured out who that biggest power is, I am going to divide everybody on the top and everybody in the bottom by x squared. Although that might not look like it, do you know what I'm doing? Is I'm multiplying this fraction by a special version of 1. I mean, it might not look like it, but I am, right? So that's why we can get away with it. Because if you really want to know what it is, aren't I multiplying by the fraction 1 over x squared, 1 over x squared, right? There. But that's weird, right? So we just write it like this. Now let's see what happens. If you divide this by x squared, you get 2. If you divide this by x squared, you get 1 over x squared. If you divide this by x squared, you get 3. The middle term, you get -4 over x, and the last term, you get 7 over x squared. Are you happy with all those terms now being divided by x squared? Are you happy about what we got, right? Now we do brute force, which is replace the x with infinities and see what happens. So it's going to be 2 plus 1 over infinity squared. 3 take away 4 over infinity, add 7 over infinity squared, right? That's the part that we call brute force, right? Okay. 2 is 2. What would 1 over infinity squared get me?
0.
3 is 3. What would 4 over infinity get me?
0.
And
And
7 over infinity squared?
0.
So -0 plus 0. Can you now see that we have the answer that it's 2/3? Now that is an exact answer, right? Remember up here we said, looking at the table of values, my best guess is it's 2/3, but couldn't the answer really be just a really long decimal with lots of 6s in it? Right? We wouldn't really be able to say for sure. Do you notice that in this method, we can say for sure that the exact limit, right? That's the real answer, right? It's not a guesstimate or a conjecture. It's the real answer would be 2/3. So far, so good. Let's try another one then. Let's do the limit as x tends to infinity of 4x cubed, take away x to the 4, over 3 plus 2x to the 4. What should I divide the top and the bottom by? What power of x is the go-to guy this time?
X to the 4th.
You agree? They both happen to have it, which is nice. In my next example, I'm going to have only one of them containing that, just to show you what happens. So we now go through each of the terms and divide them all by x to the 4. So this guy becomes 4 over x, this guy becomes -1. This guy here becomes 3 over x to the 4, and this guy becomes 2. Now, if you do brute force, you get that on the numerator. You get that on the denominator. Can you see where this is going? Would you agree that guy there is 0? This guy there is 0. The answer is -1/2. So we now know that the limit of this guy is exactly -1/2. Pretty cool. So let's make life a little bit trickier. Let's do that one. What power of x do we do the top and bottom by this time? What's the highest power of x? That's
X to
essentially
the
one.
fourth.
Now, that gets done to everybody, right? Some people at the beginning think, oh, well, I'll just divide this by x cubed and I'll divide this by x to the 4 and everything comes out fine. No, that won't come out fine. Algebraically, you're doing different things to the numerator and denominator, so it's not valid, right? So x to the 4 is the biggest. Everybody gets x to the 4. Even although that doesn't have any x to the 4s, it still gets divided. So in this case, the limit as x tends to infinity. Let's see what we get. This guy is 4 over x. This guy is 2 over x to the 4. This guy is 5. And this guy is 1 over x squared. And if we do brute force, 4 over infinity, take away 2 over infinity to the 4, 5 plus 1 over infinity squared. And we've done enough of these to know that that's 0 and that this is 0 as well. So 0 take away 0 goes on the top, and 5 plus 0 goes on the bottom. And so we have 0 over 5, and 0 over 5 is 0. So that's an example where the limit is 0. Wouldn't that be a horizontal asymptote on the x-axis? That's what it would look like if you sketched it. And the last possibility is this one. That one. Okay, what power of x will I divide top and bottom by this time?
Squared.
Okay. Let's see where that leads us to. Three. Take away 7 over x. I don't know why I paused so long on that. 1 over x squared. 2 over x plus 1 over x squared. So far, so good. Did you catch that? Somebody's phoning me. No? Oh, I'm trying to find my phone so I can switch this off. I apologize. Hey, phone, where are you? Good, it's gone away. But do you hear what I just hear in my earphones? Because evidently my thing has contacted my phone. Did you hear any of that? No. It was really annoying because it was an English voice saying, call from 355577, whatever it was saying. Really annoying. Right. So let's focus back on this guy. 3, take away 7 over infinity plus 1 over infinity squared. 2 over infinity plus 1 over infinity squared. You still with me? Right. Numerator. That 3 is still a 3. That's take away 0 That is add a 0. This is 0 plus a 0. And by the way, these are positives. That's going to be important in a minute. 3 over 0. Now, normally you have a problem with 3 over 0. We know the answer is plus or minus infinity, right? Whenever you divide by 0, it's going to go plus or minus. And so if you're going to look at this, do you notice that that is a positive version of 0? Because 2 over positive infinity, wouldn't that get you a 0 that's coming in from the plus side? And we typically put a little baby plus on that to remind us, and that's how we know that's plus infinity. Right, so you just have to be a little bit careful when 0 is in the bottom, right? Now, if that was the limit as x tends to negative infinity, can you see I might have said 0 minus here, and that would have been minus infinity. Any questions so far? Are we good? Right, so what I'm going to do is go and have a look at some of the kinds of questions that you have in the homework. And give me a few seconds to get rid of these guys. And the first few are going to be, oops, I got something in the chat and then I should know. Oh, Charles has just told me how to make an open circle. So he says from Desmos help menu. Okay, I looked it up. So to change the point from a closed circle, right, a filled in one to an open circle, click and long hold the color icon next to the expression. You can then change the dot. Oh, let me try that. Okay, this is winding back just for a few moments to what we did earlier. Right, so let's suppose I wanted to make that one an open, right? Inside there, solid dot and open dot. If I picked it up correctly, you go here and you do a long pause and you make it open. Oh, cool. Right, so the guy that I actually want to do is this one here. So where is he? At -1, 6. So I'm going to put in the point -1, 6. And there's the dot appearing, right? And then I'll do a long hold on that and I'll say, make me a circle. Yay! You see, we've completed it. We now can make little open dots and little solid dots. That is elegant. That is so cool. Thank you. That was nice of you. And can you see question 1 now? Are you looking at question 1, which has got a lot of graph? Right. In this graph, we are simply just going to look at the picture. And I might have to shrink this a little bit. So hopefully you can still see it. There. We're going to shrink this picture and find out what the limit should be. So this one is the limit as x tends to plus infinity. Right, as you're going this way, would you agree it's going to level off at, I would say, -2. The limit as x tends to negative infinity. As you go to that direction, this one here, it looks like it would level off at +2. Now, the overall limit as x tends to 1, right? There's x tending to 1, right? That's a vertical asymptote. The overall limit here would be plus infinity. So you can go there. Where are you? Infinities in symbols. There you go. Infinity. Now, what's the limit as x tends to -3? Isn't that a hole in the ground one? So that would be negative infinity. The equation of asymptotes, enter the answer as a common separated risk, right? There are 2 vertical asymptotes. There's one at x equals 1 and the other one is at x equals 3. So they want you to put x equals 1, 3. That's how you do it. That's the comma separated list. Now there is horizontal asymptotes, right? There's one over here where it levels off at 2, and there's one over here where it does -2. Those are equations y equals -2, and then y equals 2. So are you comfortable if someone gives you a diagram that you can use it to do the limit as x tends to plus infinity, the limit as x tends to negative infinity, and the limit as x tends to a number, and that number happens to have a vertical asymptote there, right? We're good with that? Right. Let's make this picture bigger. Okay. What would the limit as x tends to infinity be for this function? The limit as x tends to plus infinity.
Zero.
Is it? As x gets really big,
2.
you see the function, it's wobbling, but I would say it's wobbling at 2. Right, what would the limit then be if x tends to negative infinity? So you follow the curve, right? And as you travel this way to the left, do you see the curve is leveling off somewhere, isn't it? So what would negative, say again?
-1.
-2. And sorry, 1.
-1, right? Okay, we agree. -1. When I look at this picture, would you agree there's 2 vertical asymptotes? There's a hole in the ground at 0, isn't there? You know my name for them. A hole in the ground shape at x approaching 0. What would the overall limit as x tends to 0 be for this function?
Negative infinity.
Right? Negative infinity. There's another vertical asymptote over here at x equals 2. If I asked you for its overall limit as x equals 2, wouldn't you say the answer is it doesn't exist? But I could say, and I'm about to, what is the limit as x tends to 2 plus? So what is the limit as x tends to 2 plus? That means you're coming in from this side. Okay. And if I say to you, what was the limit as x tends to 2 minus, right, you'd be coming in from this side. Oh, something weird happened there. I just lost my picture. Yeah, it's back. I would go with that one, right? Using graphs. And these ones are a little bit easy to do, I think. They give you some instructions. That's these guys here. And you just draw a graph that has the same properties. And then it ends up being one of these 4 pictures, right? So you know you get 5 shots, so you're eventually going to get it right. But it's good to try it on your own. Number 4 is the same type of question. And now we're on to finding limits as x tends to infinities. X to the power of 5 over 5 to the power of x. And this is a really weird question. It says, do a table of values. Well, I can figure that out, right? That's a big table of values, but I could do it, right? I wouldn't need to write it down. Could I just have it in my calculator and look at it? What do you think x to the power of 5, 5 to the power of x is going to be as x gets infinitely large? I know we haven't done any calculations yet, but what do you think your gut feeling is? X to the 5, 5 to the x.
0.
I agree. I think it's going to be 0. And here's my argument for it. The answer is typically going to be 0 or infinity. Doesn't it depend on which one gets bigger faster? And I'm thinking to myself, 5 to the power of x is going to get bigger faster than x to the power of 5, right? That would be my thinking. And I'm pretty sure I'm right. And if you plug this into your calculator, you will find out that your assumption was correct. It would be 0. Now, in this one here, I'm going to have to shrink this up a little bit. You actually, oops, too much. you actually do get to fill in some table values, right? So we're doing it by the method, right? You know, the numerical method. This one says estimate the answer and correct to 2 decimal places, and then do this table, and then estimate your answer to 4 decimal places. I think they are pushing the envelope that you could look at that and make an estimate. I happen to know what the answer is, but that doesn't help. You agree it's quite hard. So since I don't know what the answer, well, I do, but I'll pretend I don't. I'm going to say 1.5 because I feel like it, right? Because there's no way in the world WebAssign should put you wrong with that. I guess I should put 2 decimal places in, right? If you plug this guy and then this guy and then this guy into Desmos, you will get a decimal that is approaching some value, right? I guess I'm going to have to jump out and in here because I'm doing too much talking and not enough showing. Right. So I'm going to try and do what they asked us to do. We have a function f of x. It's equal to 1 take away 4 over x, all to the power of x. And we're going to do a table of values. And we're going to choose x as 10,000. And then we're going to pick x as 100,000. And then I believe we're going to pick 1,000,000. And here is f of x. So I'm going to go to our calculator. I'm going to go y equals, and I'm going to type that guy in. It's a bracket. 1 take away 4 divided by x, close the brackets, raised to the power of x. Right? You agree it's a pretty weird looking function, which I don't think it's fair to expect you to guess. Right? I just guessed 1.55 because I wanted to. So I'm going to go to my table setup here, and I guess I should just pretend I'm starting from scratch. 10,000, 100,000, 1,000,000. Would you agree that the answer looks like it's 0.0183 to 4 decimal places? Does that seem reasonable? Now, my answer, which I knew was wrong when I gave you it, was 1.55, which just proves to me that I was really bad at guessing, right? Now, that actually does have a value. I'll tell you what the value is e to the negative 4. And I'm going to try and prove that by getting out of this thing and doing e to the power of negative 4. And can you see that 0.0183 that we're talking about? Now you might say, well, how do you know it's e to the negative 4? Because there's a bit of math that you'll get in Calc 3 that none of you should even be expected to know that tells me that this guy is e to that negative number. So if you make that 2, this will be e to the negative 2. If you make that plus 4 over x, this becomes e to the 4. Don't worry about that. I do not expect you to memorize that. I'm just saying that you could use a table of values, but aren't you limited to a decimal estimate because that's all you have to work with, right? So as a decimal, that would be your correct answer. And your guess can be 42 as far as I'm concerned, because I don't think it's fair to expect you to do that. Anyway, so far so good? Right, so let me just, I'll look at screen, that saves me doing this back and forward stuff. And we'll start off by finding, and so this is a version of question 8, by finding the limit as x tends to infinity of 6x plus 5 over 7x take away 1. Okay. Would you agree that you divide top and bottom by x? So this fella becomes 6 plus 5 over x becomes 7, 1 over x. When you do your brute force, you get 6 plus 0, 7 take away 0. There's your answer. Have any of you noticed that in a lot of these questions, you could probably have a very sensible estimate stroke guess at the right answer that it was going to be 6/7? Right. Now, when you're doing a lot of questions and homework, that might be fine. But when you come to do your exams, will you please remember that I need to see this? Because you're not proving that the answer is 6/7. If you're just saying, well, I've seen enough of these and I can have a pretty good guess at it's probably 6/7. I'll probably get caught out now and again with a special case, but most of the time I'm going to be fine. And that's not good math, right? But this is how you would prove it, right? And so we're talking about proving something rather than just making an intelligent guess of it. And well, I should put one in like this, I guess. In this example here, would you agree I really don't need to do anything? Can't I go straight into brute force? Right, seems reasonable. So, -5 over 8 lots of infinity plus 3. Would you agree 8 lots of infinity plus 3 is still infinite, and -5 over infinity is still 0? What about the -5? Doesn't matter. Won't infinity kill the negativeness of it? Right. 5 over infinity, -5 over infinity, they're both 0, right? Eventually, they both end up at 0. And now let's put in one that we haven't done. This is question 7. We have not seen this situation yet. So we have to adjust and adapt. Would you agree we've never seen one that looked like that before? Adjust and adapt. We're still going to use that method that we've used, right? The brute force method. But we have to somehow cope with this extra awkwardness, right? You see this square root thing going on here? Any suggestions how you might approach this question?
Would you
Mhm.
multiply it by x to the second, x squared? To get rid of the,
Oh, like square the thing?
yeah,
Okay, let's suppose I squared the thing and the final answer I got was 9. How would I be able to use that number to figure out the original answer? Because your idea sounds interesting. I'm just wondering how you finish it. So I squared it and then I found the answer was 9. What would I do next?
Reapply the root.
Could apply the root, right? So the answer would be 3. There's only one problem with that, and I like it up to this last bit. When
Plus
you
or
take the
minus.
square root, I've got the plus or minus problem.
Well, is the whole fraction underneath the radical, or is it just the numerator?
It's the whole thing. Everything's inside the square root.
Okay, well, I think we need to divide the numerator and the denominator by x to the third.
Yeah, we will. You're right. How are we going to deal with the square root? That's the issue.
I don't think we deal with the square root until after we've taking the limit.
Yeah,
Inside
that's
the table.
so. I'm going to write it like this. So what you said was good. I liked your thought, Coral. We just had a little issue at the end, right? Because we weren't quite sure plus or minus. So what we're going to do instead is different approach. I'm going to find the limit of this thing and then just take the square root of it. And I guess you could say, well, we're going to have the same plus or minus thing that we were talking about earlier. Technically, if they say it's a square root, shouldn't they just say it's positive? Oh, now I've thought about that. Coral's idea works as well, doesn't it?
Well,
If
because
that was negative, wouldn't they say a negative in front of it?
once
So I'm making that assumption. Yes.
once we
Yes.
divide everything by, you know, the numerator and the denominator both by x to the third, and then once we take the limit, that's going to leave us with 49 divided by 1, which is positive, and we can get the square root, which is 7.
Yep. I totally agree. So divide top and bottom by x cubed, which is what you said we should do. So let's show you that one. So now that I've thought about it, Coral's trick would have worked as well. So you aren't wrong, Coral. You could have got the answer. Now, I said 3 because I made that number up. It's, as you can see, it's going to be a little bit different than that. 49. 2 over infinity squared. Take away 9 over infinity cubed. On the bottom, you're going to get where did that guy come from? There we go. 6 over infinity cubed. Take away 4 over infinity squared plus 1. God, this is messy. 49. Plus a 0, take away a 0 is 49. 0, take away 0 plus 1 is 1. So we now have the square root of 49, which is 7. So that works nice. So the answer to this limit was 7. Now, if that number in the center had been awkward, because it could have been 20, for instance, right? Wouldn't the answer just be the square root of 20? If it was 42, it'd be the square root of 42, I guess. And we're assuming that since they say it's a square root and it has no sign next to it, we can make the assumption the answer is positive. Well, based on that trick that you basically don't worry about the square root until you've got the thing inside done, and then just take the square root of it, we could adapt that same method if someone went and said to you, and we're not going to do this question, I just want to do it as an example. If you wanted to do that, wouldn't you just find the limit of what was inside, just this guy, in the usual way? And then once you got that answer, wouldn't you just take the cube root of it? And if someone went and said to you, let's keep the thing the same, that I wanted to do that guy, I wouldn't FOIL that out. God, can you imagine how long that would take me, right? I would not do it that way. Wouldn't I simply just find the limit of what's inside, which is this guy, right? And once I got whatever that answer is, wouldn't I just raise it to power of 7? You see how clean that would be. So you can adapt the brute force technique to even do ugly square roots, ugly cube roots, ugly things to the power of 7 or 2 or 22. By essentially ignoring them, getting the answer to this guy, and then just raising it to the power of 7, or cube rooting it, or square rooting it. And I'm glad I did that, because I didn't put that down as one of the things that we would be expected to do. So let's try 11, or a version of 11. And they're changing the letter for the variable, which is good news. Yes. We very often get too caught up with thinking X is the only guy in town. Right. Okay, you want to do this guy. What would you divide top and bottom by in this fraction? I seen moves lip smooth, but I didn't kind of catch what they were saying. What would you do this time?
R cubed.
Agreed. And divide that by R cubed. The next one by R cubed. The first one on the bottom by R cubed. The middle one and the last one. I want to speed things up here. I'm going to do this classic one. Do as I say, not as I do. You would be expected to finish in the rest of this in a test question, right? In homework, you can do shortcuts, but in a test, you would do all the other stuff. But can I jump right to -1/7 and you are comfortable that's where I would end up, right? But you're not allowed to do that. I am, right? Remember that rule. Do as I say, not as I do. And did we get any more like that? Yeah, let's just look at situations we haven't dealt with and how we can adapt. So I'd like to know this one. And I'm not going to do all of this question. This one, by the way, is a version of 13. I'm just talking about the beginning of the process. Right, we've not seen a question like that, agreed? So adapt would be a strategy this time.
So I would simplify this first.
Okay, and by that you mean what?
Or we're going to expand all of that out.
Yeah,
and
agreed.
then I would divide by the highest power of, is that a U or a W? It's hard to tell.
They're badly drawn U's.
Okay, yeah, then divided by the both the numerator and denominator by the highest power of U, and then take the limit.
I agree. Now, the minute I write it down like that, would you agree it's a pretty standard question? Right, and do what you would do. I'm looking at that one. I think we could make a pretty good guesstimate. The answer is going to be 5. Would you agree?
Yep.
Do as I say, not as I do, right? So you would go through that one. How about this situation? So we're looking now at guys that don't fit the clean, simple model of powers of X on the top and powers of X on the bottom.
So we have under the radical, we've got t squared.
Mm-hmm.
So we're going to have to divide t squared in the radical by t square. However, we've got to do the same to the numerator, but you won't do it by t square.
Mm-hmm.
So if you were to take 5t squared minus 1 and divide it by t squared under the radical, that's also going to be the square root of t squared, which is going to be t, which you're going to divide the numerator by.
Right. Essentially, that guy in the bottom is really worth a t. Would you agree a square root of t squared is like a t? And what you were saying could make perfect sense. So I'm going to divide the top and bottom by t. I'm just going to write the version of t that best suits the guy I've got. Would you agree on the top, t perfectly suits t plus 7, right? That's a good way of writing t. But on the bottom, writing divided by t isn't helpful. Dividing by the square root of t squared, of course, is, because don't you have to have like with like if you want to divide things? Right. So based on that, the next line would be 1, 7 over t. Still have a square root here. Divide that guy, you get 5. Divide that guy, you get -1 over t squared. And again, do as I say, not as I do. Would you agree that eventually you would get that, but you would have to do the over infinities, all the zeros, and then eventually get to that line? Agree? I like things to look pretty, even although WebAssign won't. So I would much prefer that as the answer, right? Although I think WebAssign will probably take 1 over √5 because it's more generous than I am. Are we cool with that? Right. 15 is very similar to that one. 16 is pretty standard. We kind of covered all the good stuff, I think. Oh no, there's one that sneaked by. Adapt. Here's another one where we have to adapt. And there's another one after this I'm going to show you, which I just recollect. How are you going to deal with that guy? I'll tell you right now, you're still going to do that divide thing. You just have to adapt. What shall I divide the top and bottom by?
The square root of x.
Yeah. A little bit weird, but yeah, square root of x. Let's see what that looks like. Well, it's going to be the limit as x tends to infinity. 36 over the square root of x. Take that guy and you just get -1. And on the bottom, you're going to get 6 over the square root of x, and that guy is going to get you +1. I'll go in and do brute force on this one. Okay, what do you think the square root of infinity gets you?
Infinity.
Yep, and isn't 36 over infinity still 0? And so you get 0 take away 1 and 0 plus 1, so the answer is -1. So this idea of what dividing the top and bottom is pretty effective, isn't it? It can do all sorts of nuances that we may not have thought about. Now, I've promised you one more of these. I just have to find where the darn thing is because I do know it exists. And here it is. So for this one, this is actually an example of the last question. We are going to do the limit as x tends to infinity. And this is actually, I think, the only question that looks even vaguely like this one. So we're going to adapt. And we're going to stick to our tried and trusted method of finding something to divide the top and bottom by. Any suggestions? Divide top and bottom. What do you think?
E to the x?
Yeah. In a way, isn't it the only thing that is a candidate? Right? There's not really much else there. So even if you weren't sure, wouldn't that be your go-to guess if you had nothing else to think about? So let's see what happens when you divide each term by an e to the x. Well, that becomes 6 over e to the x, and that becomes -1. And this becomes 6 over e to the x, and that guy becomes 5. And now I'll do brute force. wouldn't e to the power of infinity be infinite? And isn't 6 over infinity going to get me 0? And that's 0 plus 5. So my answer ends up being negative 1/5. Now we have very little time, so I'm going to talk through the last two situations. So while I'm getting set up, why don't you put your last name down for attendance? And there are two questions I want to look at. So it looks like everybody's done that. Right, the first one I want you to look at is question 17, which is really quite exceptionally different. Can you trust me that WebAssign has written this really weirdly? I don't know why it's formatting so bad, but this is basically the square root of 49t squared plus 6, take away 7t. Do you notice the 7t looks a little bit high and weird, but that's what it really is, right? It's just the square root of 49t squared plus 6 minus 7t, right? We have not tackled this guy before, but we have done this method before. And I am not going to divide the top and bottom by a special version of 1, right? Like divide top and bottom by t squared or t or whatever. I'm not going to do that. I am going to multiply the top and bottom by a special version of 1 with a funny name that starts with a C.
Conjugate.
Right. So you are going to multiply this expression, top and bottom, by the square root of 49t squared plus 6, add 7t, right? Top and bottom. And when you do that, some miraculous algebra is happening, and you'll be able to come up with the answer. And the answer ends up, I believe, being 0, but you'll check it. And question 19. Never seen this guy before. Any suggestions?
So with e raised to the power of negative 5x, e raised to any power is going to be 0 when you take the limit.
Okay.
It's going to
Right,
be
e to
0.
the minus infinity is going to be
So it's going to be
okay.
so it's going to be 0 times cosine of x, which is going to give you 0.
Oh, interesting. Okay, let me just make an alteration to that. E to the negative 5x is the same thing as 1 over e to the 5x. Great. And if you do a brute force on that, that gets you 0, right? So we're arguing about that. And isn't 0 times the cosine of anything still going to be 0? So yeah, so I would agree with that. I just maybe phrased your logic a little differently, but that would be 0. Oh, I guess I didn't notice that one. I should look at that one again. How are you going to tackle 18?
You're going to factor out x to the 4th. And once you do that, then you can take the limit, which is going to be negative infinity times 1 plus 2 to the 5th.
Okay. And then just do brute force calculations.
Yeah, because infinity times anything is going to be infinity. So
sounds like a good plan. Yeah. So don't you just kind of look at something and adapt it, right? Play about with it, rewrite it, whatever it's called. Yeah, I agree with that. That would work. You could have also pulled out x to the 9 and done a similar result, but both ways work, so nothing wrong with that. Wow, we are good. 3 minutes to go, but 2 minutes to go. And you've already done attendance, so bye-bye for now. I will see you tomorrow. I'll hang about for any questions. And we have finished that section. So that's a nice place to stop.